Hey everyone, welcome back to the channel. Today we are going to solve a great coding problem called the minimum size subarray sum. This is a problem that appears frequently in coding interviews and really tests your ability to work with subarrays and sliding windows. We'll break down the problem, go over and optimize the solution in C#, and explain each line of code along the way. I'll also share some of my personal experiences with problems like this. So let's get started. Here's the setup. We have an array of positive integer called nums and an integer target. Our goal is to find the smallest contiguous subarray whose sum is greater than or equal to target. If no such subarray exists, we return 0. Let's look at an example to make this clearer. If target is 7 and nums is 2, 3, 1, 2, 4, 3, the smallest subarray with a num of at least 7 is 4, 3, which has a length of 2. So we return 2. Pretty simple, right? When I first saw this problem, my initial approach was to try all possible subarrays, checking if each one met the target. But that brute force method quickly became inefficient. Then I came across a sliding window technique, and it completely changed my perspective on how to approach problems like this. This technique is really powerful for any problem that involves finding subarrays or contiguous subsequence. The optimized solution uses what known as sliding window technique. Here's the idea. We'll keep a window that starts at the beginning of the array. We expand the window by moving one end to the right until we meet or exit the target sum. Then we meet the target, we start shrinking the window from the left to see if we get a smaller subarray that still meets the sum requirement. This approach allows us to keep track of potential solutions without having to recheck every subarray from scratch. Alright, let's dive into the code and walk through each line by line. Let's go through it. So understand exactly what's happening. We start by defining a method called min subarray length, which takes in the target sum we are aiming for and an integer array nums. The method returns an integer which is the minimum length of the subarray that meets or exceeds the target sum. Next, we initialize three variables. Min length is set to int.maxValue, which will update when we find smaller subarrays. Left is our left pointer for the sliding window, and current sum will hold the sum of the elements within the current window. Now we enter a for loop where right is our right pointer. It goes from the start to the end of the array. With each iteration, we add nums right to current sum, expanding our window. Inside the loop, we check if current sum is greater than or equal to target. If it is, we know we have found a valid subarray. So we calculate the length of the current window, right minus left plus 1. If this length is smaller than our min length, we update min length. Once we have recorded the current subarray length, we shrink the window by subtracting nums left from current sum and moving left one position to the right. This shrinking process helps us find the smallest possible subarray that meets the sum requirement. After the loop completes, we check if min length has been updated from its initial int.maxValue. If it hasn't, we return 0 because that means no subarray matches the target sum. Otherwise, we return min length, which is our answer. To sum it up, by using sliding window technique, we are able to solve this problem in O and time complexity, which is much more efficient than a brute force approach. This technique is really powerful, especially for problems that involve subarrays or subsequences where you need to find the minimum or maximum length. Personally, working on problems like this has helped me see how sliding windows can be applied to all sorts of real-world coding challenges. I remember when I first learned this technique, it opened up a whole new way of thinking about subarrays and sequences. Alright, that's it for today's video. If you found this video tutorial helpful, please give it a thumbs up, subscribe and hit the notification bell so you don't miss any new videos. And as always, let me know in the comments if there's any specific problem that you'd like me to cover next. Thank you for watching.